Hello children, welcome to a new session. In this session, we will discuss about continuity. It is a part of the chapter Continuity and Differentiability. My name Kavitha is Nair, Faculty of Silver Hills Public School, KOZHIKODE, handling Mathematics, Class 12. Now, what do you mean by continuity? That means in a common language or in simple sentence, if we are able to draw the graph of a function in a plane of paper without lifting the pen continuously, then we will say it is continuous. Okay. Now, let us see some examples to understand what you mean by continuity and what you mean by discontinuous, and go to the definition and some problems relating to that. Here we can see a function f of x equal to 1 if x less than or equal to 0, equal to 2 if x greater than 0. Let me come to the graph to make it more clear. At the point 0 and less than 0, when x takes the value 0 and behind it, the function is having common nature. What is the value? 1. That means from minus infinity, the real plane, we are discussing in the real plane, it is coming from minus infinity. So, from there onwards up to 0, x equal to 0, it takes a common value 1. It is continuously coming. But at that point 0, it is stopping, then right to 0, that means more than 0, it is changing its value to. So, here it is a hole, from there it is having same nature. Here the real line is broken at the point 0, and at that point we are lifting the pen. From here we are drawing continuously, then lifting the pen, then again drawing. That means it is having a discontinuity at the point x equal to 0. Clear? Let us see one more function. A similar little bit difference. F of x equal to 1 if x not equal to 0. That means, let it be greater or less than. Then also the value is 1, and at 0 it is taking the value 2. When x equal to 0, it is taking the value 2. When x is other than 0, it is taking the value 1. But from minus infinity we started the graph, reached here, lifted the pen. At 0 we marked here, then started again. There happened a break. So, we will say in this case also the function is discontinuous at the point x equal to 0. Now, keeping this both graphs in mind, let us define what you mean by continuity of a function. Suppose f is a real function on a subset of real numbers and C be a point in the domain of f. C is also a real number. Then f is continuous at C. When we will say it is continuous? Limit x is tending to C. X is approaching to C. F of x, it will take the value f of C. That is, more clearly if we say the left hand limit, right hand limit and the value of the function at x equal to C exist and equal to each other, then f is said to be continuous at x equal to C. That means in real line C is somewhere a point. We can come to C from left side or right side. If you come through any way, either from left side or right side or directly to the point, the three values should become unique. Then only we can say the function is continuous at the particular point C. Let us do some example keeping in mind this definition. Okay. Check the continuity of the function f given by. Here the function is having same nature everywhere in the domain. It is not restricted when x is less than 0, x is greater than 0, x is less than 1, greater than 1, nothing. Everywhere it is nature is same. So, if you approach through left side or right side of x equal to 1, both way it is having same value. Let us see f of 1. We are giving, here our c is 1. We are giving x equal to 1. So, 2 into 1 plus 3. 2 into 1, 2 plus 3 makes 5. Here, left hand limit if I take, limit x is tending to 1 minus to left side, f of x. Then also the value is not changed. Correct? When we take from left side, that means close to 1 but not 1. Every time let us take a positive value h, a real value greater than 0. It is a very minute value. Okay? So, from 1 if you minus that h, it will be a number less than 1. So, limit h will be tending to 0. We can write f of 1 minus h. Correct? 1 minus that small positive number will be left of 1. But left of 1 or right of 1, the function is having same value. So, we can write limit h is tending to 0, 2 into 1 minus h plus 3. Which will be equal to limit h is tending to 0. So, this will be 2 minus 2h plus 3. When h is tending to 0, the 2h will become 0. So, 2 plus 3 makes 5. Correct? Again, if you take a limit x tending to 1 plus f of x, same way h is a small positive number. So, we will write limit h is tending to 0, f of 1 plus h, just right of 1. So, in the place of x, limit h tending to 0, 2 into 1 plus h plus 3. It will become equal to 2 into 1, 2 plus 2h plus 3. When h is tending to 0, 2h will become 0. So, 2 plus 3 will make the same value 5. So, what can you see from here? F of 1, limit left side, limit right side. 3 of them are same. So, we can see from here the value of the function when x equal to 1, when we approach through left side and we approach to right side, 3 of them are same. What we mean by that? Just previously we saw the definition. What is the meaning by continuity of a function? So, we can say in this case the function is continuous at x equal to 1. Coming to next question, a very important function, the modulus function, f of x equal to mod x. Now, what do you mean by mod x? F of x equal to x when x greater than or equal to 0 and it is equal to minus x when x is less than 0. It is having two natures. Now, let us see how to check the continuity of this function at x equal to 0. Now, let us take f of 0. We are checking at 0, our c is 0. At 0, when x takes 0, we can see here x equal to 0. What is the nature? X itself. What is x? 0. So, we will get 0. Clear? Now, let us take the LHL. We are going to approach 0 left side from left side. So, limit x is tending to 0 minus f of x. Correct? We are going to write one h. As I said previously, h is a very small positive quantity. When from 0 you subtract h, we will be left of 0. So, limit h tending to 0, f of 0 minus h. Correct? Now, again, limit h tending to 0, left of 0. Left of 0, the second definition. What is the nature? Minus x. So, what comes in the place of x? 0 minus h. So, it is minus 0 minus h. H is tending to 0. So, what will be the value? 0. Now, let us see the right hand limit. Limit x tending to 0 plus f of x. Limit h tending to 0, f of 0 plus h will be equal to limit h tending to 0. What is 0 plus h means? More than 0. What is the definition? X greater than or equal to 0, it takes x. So, we will write 0 plus h. Again, h is tending to 0, so we will get the value 0. Value of the function at 0, left limit, right limit, everywhere you get the value 0. What does it mean? The modulus function is continuous at x equal to 0. That is the conclusion. Coming to next question. Show that the function given by is not continuous. Okay. Here the domain is defined x equal to 0. It takes the value 1. When it is not 0, it is taking the value x cube plus 3. Let us see how to check the continuity. F of 0. Our c is 0 here. When x equal to 0, the value of the function is 1. Now, let us take the LHL. Limit x tending to 0 minus fx equal to limit h is tending to 0. As before, a small positive quantity, left of 0 means f of 0 minus h. Whether left of 0 or right of 0, it takes x cube plus 3. So, limit h tending to 0, 0 minus h whole cube plus 3. This is a function. We replaced x by 0 minus h. 0 minus h whole cube will be minus h cube. When h is tending to 0, what we will get? 0 that place. The remaining one is 3. Equal to 3. Correct? Now, the right hand limit. X tending to 0 plus f of x. We will get limit h tending to 0 f of 0 plus h equal to limit h tending to 0. Again, other than 0, everywhere it is having x cube plus 3 nature. So, we will write 0 plus h whole cube plus 3. 0 plus h whole cube is h cube. H is tending to 0. So, that part will become 0. Then the remaining 3. So, the value will be 3. Here, we can see the value of the function at 0 is 1. But left and right both are different. These both are same, but it is not equal to f of 0. The 3 of them should be equal. Value of the function at the point, the left hand limit and the right hand limit, 3 of them should be same. Here this is 1 while the other 2 are 3. So the function is discontinuous at x equal to 0. Now another important function, greatest integer function or the box function. The graph is shown here. About the graph I will discuss last. Now let me explain what you mean by a box function through some examples. What is it? Where box x denotes the greatest integer less than or equal to x. Let us take some examples and show what you mean by the box function, how to find the value. If I take box of 1.2, what will be the value? The value will be an integer less than or equal to 1.2. Which is the integer? It is 1. Correct? If I take 0.999, what is box of 0.999? It is the greatest integer less than or equal to 0.999. Which is that one? 0. So its value will be 0. Another example, if I take 2.999 box of this one, the value will become a number less than 2.999, integer, integral value, which will become equal to 2. Now you might have understood how to find the value of the greatest integer function. Now, to discuss about the continuity of greatest integer function, we have to consider 2 cases. When it takes integral value, that means the c which we are taking from the domain, it will take the integral value or a non-integral value. Okay? Let us take case number 1. Case number 1. When c is an integer. So what we are going to check? When we are taking an integer. Through that integer, we are coming through left side, right side, and the value at that integral point. 3 of them, whether they are unique or not, let us see. I'll show one example this side, then come to the original part. So c is an integer. So let me take the c for an example 1. H, a small positive quantity. Let me take a number less than 1. Less than 1. So let me take here h as equal to 0.001. So when we take c minus h, we will get 1 minus 0.001. It is equal to box of 0.999 and the box value, as I said the example previously, it will be equal to 0. Okay, let me take c plus h also. Box of c plus h equal to, c takes the value 1 plus 0.001, 0.001, it will be equal to 1.001, which will be equal to 1. Okay. Now, box of c means box of 1 equal to 1. Now, please look here. We took c as an integral value. We approached through left side. We got a number 1 less than the integer which I took. I took the integer 1. 1 less than 1 means 0. I approached to right side, c plus h. We got same integral value which the integer I took 1 itself. C, its value is 1. Now let us come to the theory part and explain. You might have understood when you approach a integer from left side and right side, the limit values are different. Yes? So, if we take the function f of x as box x, limit x tending to c minus box x will be equal to limit h tending to 0 box of c minus h. What will we get? From c, we are subtracting that h, we will get the value as c minus 1. The integer which we took, minus 1. If we are taking limit x tending to c plus box x, we will get limit h tending to 0 box of c plus h, and its value will be equal to c. And value of the function, here we can see f of c will be equal to box of c, and being an integer it is equal to c itself. Now the value of the function at c, left limit is c minus 1, right limit is c. You can see they are not unique, 3 of them are not unique. So at integral points, the box function is discontinuous. Now, let us see at non-integral points. Case 2. Let c be a real number, not an integer. We are taking other than integer any value. It can be real number, right? For example, I am taking c as the value 1.2. Example, h as a value positive, same, let h be equal to 0.001. So, when you take c minus h, that means the value 1.2 less than that, a little bit less than 1.2. 1.2 minus 0.001. Box of that, you will get how much? 1.199. Correct? What is the box value? It is equal to 1. Clear? If we take c plus h, that means 1.2 plus 0.001. We will get equal to 1.201, whose box value is 1. Again it is 1 itself. When we take box of c means box of 1.2, that also 1. Here we can see the underlined 1, here 2, 3. 3 of the places it is unique value 1. That means if we are taking a non-integral value, either left side or right side to it, if we approach, the limit is not having any change. So, in conclusion, the box function, greatest integer function, is continuous at non-integral points. So, c is a real number. So, when you take a limit, x is tending to c minus f of x equal to limit h tending to 0 f of c minus h. If you are taking, then you will get h tending to 0, box of c minus h, which will be equal to box of c. If we come to right side, limit x tending to c plus f of x equal to limit h is tending to 0, f of c plus h, we will get limit h tending to 0, box of c plus h, again we will get equal to box of c. And directly when you apply f of x, when we give c, it will be equal to box of c. Now we can see 3 of them are unique. So, the greatest integer function is continuous at non-integral points. Now let me show the graph to you. You can see the graph. In the graph you can see here at integral points you can see the holes. Integral points you can see holes, which indicates that it is not continuous. Other than that, that means from other than 0, not 0, close to 0, right to 0, up to not 1, in excluding 1, left of 1. It is having same nature, isn't it? It is continuously we can draw without lifting the pen between integers. Yes, so the function is continuous at non-integral points, discontinuous at integral points. We can see like step, so it is also called a step function. Now, let us discuss the continuity of a sine function, a trigonometric function. So, what is our f of x here? Sin x, correct? If it is continuous for sin x, if you are getting conclusion, we can see about other trigonometric functions also, it will be continuous. Now, when we start to do this function, we should keep in mind limit x tending to 0, sin x is equal to 0. So, here as before we did, we will take a real number c. So, x, let us suppose x as c plus h a small positive quantity. When x tends to c, what happens to h? H will tend to 0, correct? So, limit x is tending to c, f of x, we can write as limit h tending to 0, f of c plus h. What was our f of x? Sin x. In the place of x, we are going to write c plus h equal to limit h tending to 0, sin of c plus h. What was sin of a plus b? Sin a cos b plus cos a sin b. So, let us expand this part equal to limit h tending to 0, sin c cos h plus cos c sin h. Now, let us distribute this limit and give equal to limit h tending to 0, sin c cos h plus limit h tending to 0, cos c sin h. Now, h is tending to 0, which will affect cos h. Sin c is a constant, so we can take sin c. When h is tending to 0, cos h will become 1. So, sin c into 1, sin c itself, plus what will happen here? Here h is tending to 0, sin h, cos c is constant, which can be taken outside, limit sin h, h tending to 0, which is 0. So, 0 equal to sin C. So, what we got? We are approaching from left side or right side. If you approach, you will get same value. We can see if you put C minus H, then also we will get the value sin C. Let us see when we approach through left side, what happens? Limit x tending to C minus f of x will be limit h tending to 0 f of C minus h equal to limit h tending to 0 sin C minus h. As previous, let us expand sin C minus h equal to limit h is tending to 0 sin C cos h minus cos C sin h. Let us distribute the limits. Limit h tending to 0 sin C cos h minus limit h tending to 0 cos C sin h equal to sin C is constant. When h is approaching 0, cos h will tend to 1. So, here comes sin C minus cos C is constant, h is tending to 0, sin h will tend to 0. So, minus 0, you are getting sin C. Also, f of C will be equal to sin C. That means the value of the function at C is sin C. Left limit is sin C, then right limit also is equal to sin C. So, what can we conclude? The sine function is continuous everywhere. And you can remember or recollect in class 11 you studied the graph of sine function, like waves it is moving, it is continuous without a break. Keeping this in mind, you can prove cosec x is continuous, cos x is continuous, tan, cot, sec. That means all trigonometric functions are continuous. Coming to another question. The function is equal to mod x plus 3 when x is less than or equal to minus 3, equal to minus 2x between minus 3 and 3, 6x plus 2 when it is more than 3. So, the domain is broken, the real line is broken into parts. One place it is minus 3, second is 3. So, between, that means left of minus 3 it is having same nature. Between minus 3 and 3 it is having again a different same nature. More than 3 it is having again the common nature. So, in between minus infinity and minus 3 it is having same nature, minus 3 and 3 same nature, and more than 3 again different same nature. So, chance for discontinuity will arise at minus 3 and 3 only. So, let us check at minus 3 and positive 3. We are going to take C as our minus 3. Correct? So, what will be f of C? Will be f of minus 3. What is f of minus 3 here? When it is minus 3, when x is equal to minus 3, it is taking mod of x plus 3. So, mod of minus 3 plus 3. Mod of minus 3 is 3. 3 plus 3 makes 6. Now, let us take h as previous, a small positive quantity, and approach through left side, that is LHL. Limit x is tending to minus 3 minus f of x equal to limit h is tending to 0, f of minus 3 minus h. From minus 3, a minus h is taken outside. So, when it is less than minus 3, what is the nature? Mod of x plus 3. In the place of mod x, we are going to replace by this minus 3 minus h equal to limit h tending to 0 mod of minus 3 minus h plus 3. What will it become? Mod of minus 3 minus h, h is tending to 0. You will get mod of minus 3, which is 3, and plus 3 makes 6. Now, limit x is tending to minus 3 plus fx. We are approaching minus 3 through right side. Limit h tending to 0, f of minus 3 plus h. Limit h tending to 0. When it is more than minus 3, x greater than minus 3, it takes minus 2x. So, minus 2 into, where you see x, minus 3 plus h. Minus 3 plus h equal to, when you open the bracket, you will get minus 2 into minus 3, positive 6, minus 2h, h is tending to 0. So, answer will be 6. What can we see? At minus 3, value is 6. When we come through left side to minus 3, again it is 6. When you come to minus 3 through right side, again it is 6. So, conclusion, the function is continuous at x equal to minus 3. There is one more part. We have to check at 3 also. Let us take x equal to 3. When x equal to 3, when x is equal to 3, it is 6x plus 2. Let us substitute. 6x plus 2. X is replaced by 3. 6 into 3, 18 plus 2 makes 20. Now, let us see the LHS. Limit x is tending to 3 minus fx. Limit h tending to 0, f of 3 minus h. Limit h tending to 0. What is the definition when it is less than 3? Let us see. When it is less than 3, minus 2x. Let us substitute. Minus 2 into 3 minus h equal to, what comes? Minus 2 into 3 minus h. H is tending to 0. What value will you get here? Minus 2 into 3 minus 6 plus 2h. So, answer minus 6. Correct? Next, limit x tending to 3 plus f of x. We are going to take the right hand limit. Limit h tending to 0, f of 3 plus h. Limit h tending to 0. What will happen when h is tending to 0? 3 plus h, more than 3? More than 3, 6x plus 2. Correct? So, 6 into x, 3 plus h plus 2 equal to 6 into 3, 18 plus 6h plus 2. H is tending to 0. So, you will get 18 plus 2, 20. Here, we can see the value of the function at 3 is 20. Left hand limit is minus 6. Right hand limit is 20. They are not unique. So what is the conclusion? The function is discontinuous at x equal to 3. Coming to another one example. F of x equal to 3 when it is lying between 0 and 1. Equal to 4 when between 1 and 3. Equal to 5 between 3 and 10. Here we can see the domain is restricted to 0 to 10. Closed interval 0 to 10. That means we have to check the continuity only between 0 and 10. Less than 0 what happens and more than 10 what happens? We have nothing to do with it. We have to check only between 0 and 10. At 0 and 10 is broken at where and all? At 1, at 3. So, two places we have to check, because from 0 to 1 it is constant 3 itself, constant function is continuous. Again from 1 to 3 it is again another constant 4, that place also it is continuous. From 3 to 10 again it is a different constant 5, there also it is continuous. Now let us check at the point 1. When C is taking the value 1, what will be your f of C? F of 1. When it is x is equal to 1, it takes the value 3. Correct? Now, limit x tending to C minus fx equal to a small quantity less than 1. Limit h tending to 0, f of, what is here C? 1. 1 minus h equal to limit h tending to 0, less than 1 means, less than 1 it is taking 3. So, value, there is no h here, so constant itself 3. Correct? Now, if we come through right side, x is tending to 1 plus fx, it will be limit h is tending to 0, f of 1 plus h, limit h tending to 0. When it is more than 1, what happen? X is greater than 1, it takes 4. So, answer is 4. 3, 3, 4. They are not equal to each other. So, conclusion, at 1, the given function is not continuous or discontinuous. Now, let us check at x equal to 3. X equal to 3. F of x will be f of 3. And what will be f of 3? F of 3 at x equal to 3, it is taking the value 5. Now, let us approach through left side. Limit x tending to 3 minus fx. Limit h tending to 0, f of 3 minus h equal to, at 3 minus h less than 3, when x is less than 3, it is 4. Limit h is tending to 0, 4, there is no h there, so answer is 4 itself. Clear? Right hand limit, limit x tending to 3 plus f of x, limit h tending to 0, f of 3 plus h equal to, when it is taking more than 3, x is more than 3, the value is 5. Limit h tending to 0, 5, answer is 5. Here also we can see at 3, the value is 5, left hand limit at 3 is 4, right hand limit is 5, they are not same. So what can we conclude? The function is discontinuous at x equal to 3. So generally total conclusion, at 1 also it is discontinuous, at 3 also it is discontinuous. So 2 points of discontinuity, x equal to 1 and x equal to 3. Till now we did the sums in which to prove either they are continuous or discontinuous. There is one more type in which we will say, or we will find the value of the constant given when the function is continuous at the indicated values. Here, find the value of k given function is continuous at x equal to 3. What does it mean? When you take the value x equal to 3, come through left side or right side, 3 of them are unique. Okay, so that is given to you. The value of the function at 3, LHL at 3 and right hand limit at 3. 3 of them are unique. Here it is set at x equal to 3 and x not equal to 3. That means LHL or RHL both will take same nature. So we will select one among that only. So it is given continuous at x equal to 3. That means limit x tending to 3, both LHL and RHL, f of x will be equal to f of 3. Correct? So limit x tending to 3, what can we take? Limit x is tending to 3, x square minus 9 divided by x minus 3 equal to f of 3 is equal to k. Look this function, can we factorize? It is a square minus b square form, correct? It is a plus b into a minus b. So limit x is tending to 3, x plus 3 into x minus 3 divided by x minus 3. Here you can see a same common factor x minus 3 which will get cancelled, equal to k. Continuing, limit x tending to 3, x plus 3 equal to k. Now we can give x equal to 3, 3 plus 3 makes 6. So value of k is 6. Correct? The same type, again a question. Find the value of k when the given function is continuous at x equal to pi by 2. Correct? Now let us find the value. What will be the value of k? Limit x is tending to pi by 2 minus, if you take also, or pi by 2 plus also, it is having same nature. F of x equal to limit h tending to 0, f of pi by 2 minus h equal to limit h tending to 0, k, where we see x we will replace by pi by 2 minus h, cos of pi by 2 minus h divided by pi minus 2 into pi by 2 minus h equal to, k is a constant, we can take it outside, k, limit h tending to 0. What is cos 90 minus theta? It is sin theta. Sin h divided by, here when you open the bracket, 2 pi by 2. So it will get 2 and 2 will get cancelled. Pi minus pi 0 minus 2 into minus h will make 2h. 2h. Correct? 2 we can take outside, k by 2 into limit h tending to 0 sin h by h. What is this part? As I said to you, it is equal to 1. So, equal to k by 2. If you check the right hand limit also, it will become similar. So, x equal to pi by 2, the value of the function is 3. It is set continuous at x equal to pi by 2. So, we can write it will be equal to f of pi by 2. Correct? So, that is 3. So, k by 2 equal to 3 means k equal to 6. Coming to again a different question. This is a question little bit long. Here at pi by 2 it is having same nature p. But LHL and RHL at pi by 2 are different. So, to find the constant P and Q here, you have to take both the conditions different from the previous two questions. You have to take LHL, RHL and the value at pi by 2 P. Here directly we can write f of pi by 2 is equal to P. This we will utilize after finding LHL and RHL. Equate 3 of them, then the get value of P and Q. Now, let us take the left hand limit at pi by 2. Limit x tending to pi by 2 minus fx equal to limit h tending to 0 f of pi by 2 minus h equal to limit h tending to 0. What is pi by 2 minus h? That plays the value of the function. Let us see. 1 minus sine cube x by 3 cos square x. Okay. 1 minus sine cube x divided by 3 cos square x. XI replaced by pi by 2 minus h. Now, limit h tending to 0, 1 minus, what is sine 90 minus theta? It is cos theta. So, it will become cos cube h divided by 3 cos square pi by 2 minus h. What is cos 90 minus theta? Sin theta. So, it will become 3 sin square h. Numerator is in the form of the identity a cube minus b cube. What is the expansion? A minus b into a square plus ab plus b square. Let us expand using the identity. Limit h tending to 0, a minus b, 1 minus cos h, a square plus ab plus b square. 3 sin square h. Now, we can give h equal to 0 here. Cos h will become 1. Cos square h also 1. Here 1. 1 plus 1 plus 1, 3. The 3 and the denominator 3 will get cancelled. When we apply the limit to second bracket, it will become 3 and the 3 with denominator will get cancelled. Remaining limit h tending to 0, 1 minus cos h by sin square h. What is 1 minus cos theta? 2 sin square theta by 2. So, equal to limit h tending to 0, 2 sine square h by 2 by sine square h. This is the function there. In order to get the limit, let us divide the numerator and denominator by h square, equal to limit h tending to 0, 2 into sine square h by 2 by h square, denominator sine square h by h square. Here we can apply the limit if it was h by 2 whole square. H by 2 whole square means h square by 4. Let me divide by 4, multiply by 4 to balance. So, taking this 2 by 4 outside, it will become 1 by 2. Limit h tending to 0, sine h by 2 by h by 2 whole square. Again, limit h tending to 0, sine h by h whole square. H is tending to 0 means h by 2 also will tend to 0. This part is 1, this part is also 1. So, you will get the value 1 by 2. So, let me give this as equation number 1. The left hand limit at pi by 2 became 1 by 2. Now, let us look the right hand limit. Limit x tending to pi by 2 plus fx equal to limit h tending to 0, f of pi by 2 plus h equal to limit h tending to 0. What is pi by 2 plus h? The definition, q into 1 minus sin x by pi minus 2x whole square. Q into 1 minus sin x divided by pi minus 2x whole square. Correct? Equal to q we can take as constant outside. Limit h tending to 0, 1 minus sin 90 plus h will become cos h divided by, when you multiply 2 inside, 2 into pi by 2, 2 and 2 will get cancelled, pi minus pi 0, then comes 2 into h. 2 into h whole square makes 4h square. 4h square. Let us take the constant outside. Q by 4, limit h tending to 0. As before, what is 1 minus cos h or what is 1 minus cos theta? 2 sin square theta by 2. 2 sin square h by 2 by h square. Correct? This 2 also let us take outside. 2q by 4. Limit h tending to 0. Sin square h by 2. Here, let me take it as, make it h by 2 whole square. That means, if I make h by 2 whole square, it was only h square here, I divided by 4, so multiplying by 4 here to balance. Here 2 and 4 got cancelled here 2. This 2 and 4 which comes outside makes 4 into 2, 8 equal to q by 8 into limit h tending to 0 sin h by 2 by h by 2 whole square equal to q by 8 into 1 q by 8. Equation 2. Now, what we got? We can see at pi by 2 it took p, at LHL 1 by 2, RHL q by 8. It was given the function is continuous at pi by 2, so we shall equate. Therefore, from 1 and 2 and from the value of p equal to 1 by 2 equal to q by 8. When we take this part, you will get directly the value of p as 1 by 2. Take the other part, you will get the value as q equal to 4 and p equal to 1 by 2. That is the conclusion. P took the value 1 by 2 and Q took the value 4. Now, this was the part continuity from the chapter continuity and differentiability. Hope you understood continuity properly and please practice it. In the coming session, we will discuss about differentiability. Till then, bye.